So on a set where we go next with this idea of punch facades with examples, we're leading up to actually doing a project, and this project is really still in its development stage. You'll be the first group that will go through this. And so I wanted to touch on some kind of basic concepts behind why I'm suggesting this project for us to look at. So, and this is this is actually just an extension of the paper that I published that I'm going to present at Facade Tectonics. And then this is really the lead into where I think we should go with it. The idea of detailing these punch facades. So you remember we redid or didn't redo for all of you, you didn't have the computer viz facade development that actually culminated with that idea, the first idea of a punch facade system, where we looked at extruding some material, creating a decorative facade. And I'm moving to the idea now that we can actually start to look at the details of this construction system. And the reason for that is to understand the concept of the material we're using, its mass, what its significance is in hanging on the building, the complexities of the connection systems or the mounting systems that we need, the issues of thermal breaks, where insulation systems will go, all at the same time as an architect trying to make something that's beautiful and affordable and has a low carbon footprint. So we have really an immense amount of responsibility. And one of the ways I thought we would start to help you grapple with that is in the idea of starting to go through and use the technique of making a digital mock-up kind of as a learning tool. And it can also be a development tool for you as you go through these kind of processes. So instead of saying, I want the facade to look like this and I make shapes and forms, you go, the facade will look like this based on these materials that are creating these shapes and forms that are anticipating the need for insulation, the need for thermal breaks, lightweight construction or mounting systems that maybe don't use aluminum, which has a high carbon footprint. So there's all kinds of this idea of working it into the idea of a digital visual mock-up. So you can have discussions with people, so you can run these ideas through your head, so you can look for opportunities to innovate in the way you do that. And so there's nothing really new about the idea of making mock-ups. They are great ways to explain our ideas, to get a first-hand physical idea about what's going on. But the idea of a digital mock-up really is kind of facilitated by the fact that we have really good software now to do these kind of modeling details in, and we really can create compelling outputs, realistic outputs that give us a really good idea, sensitivity to the design issues that we're grappling with. And obviously that's not new territory. This is one first in architecture. They provide all kinds of 3D, I think, SketchUp-based architectural detail models that help architects to grapple with these kind of complex assembly areas. And I'm just really suggesting that we use that same technique. So the first kind of punch facade I want to just kind of show you is a kind of a stimulus towards this idea of thinking about punch facades. And I'm really going to focus leading up to the project on terracotta because of my experience with it, because of its fluidity of creating all kinds of forms. But we also realize it has a heavy carbon footprint. You may decide that you want to use another material. You can use metal. You can use the thin porcelain materials. You can use the thin granite materials. Really, anything you want to choose to use that would actually be quite fine in this project. But for the discussions going forward, I'm going to talk about some terracotta projects and the manufacture of terracotta. So here we have SOM's Disney New York headquarters. This is a new project. These are probably just digital renderings of it. I do have some finished versions of it, I'll notice. But here we have terracotta. This is not done by Boston Valley, but by NBK, a European competitor. This is actually the facade as it looks. I don't think it's quite that kind of green that the original renderings had. That might have been just changed in the concept. But in the write-up of this, I noticed this was kind of a significant statement. A shift away from double glazed glass facades also has environmental benefits, especially in terms of energy use and heat gain. What Coop mentioned in the design team had New York City's new code requirements in mind when designing this building. So what's going on there is they're realizing that this punch facade concept means that we're reducing the amount of glass area. We're not looking at just double glazed glass facades. We're looking at things that have opacity to them, and that opacity gives us a chance to add that insulation and create higher performing sections within that area. It also reduces the amount of glass area that reduces the solar gain, which means that we need less energy for cooling systems. And you might say, well, won't that add to heating in the wintertime? But typically what happens in northern climates is that the solar gain from a window on an exposed window never achieves more energy input into it than it loses through thermal radiation back out again. So we really can't add windows to a building in a northern climate that will actually create energy efficiency. And I do want to mention one again, this idea that New York City has new code requirements for the performance of buildings. This one didn't have to meet it because it was probably already off the drawing board by the time the new code came in. But this is going to really affect the way we think about building facades in New York City, and eventually that's probably going to filter out to all of New York State and probably the country as we look towards creating more efficient, lower impact buildings. And I think I went in the wrong direction. So this is a larger view of that facade system. This is very similar. So this is actually seems to be happening as a trend, this idea of the punched facade becoming much more popular. I think it's not just from the ideas of energy efficiency, but the kind of aesthetics that's created with it that looks more traditional to the way architecture is built in cities and urban fabrics, getting away from that feeling of a glass box. And so this is 10 Bond Street by Seldorf Architects. This one was done by Boston Valley Terracotta. I saw this a few years ago, and it really kind of startled me into startled, it might be an exaggeration, but really piqued my interest in really thinking about facades in a different way. This is kind of a close-up detail, but what I think is neat about that is this is not real. This is a computer rendering. If you click on this, it'll take you out to a website, and maybe I'll just click out to it for a minute. So this is by a company WeDo, and these are actually just computer renderings before the building was constructed. So this detailed section of a building here, this assessor, this kind of like contributing structure around the building that might have been used in part of the discussion about why this building looked the way it did, what kind of materiality was used. You can see that this is also a kind of a punched facade. You can see the same, almost the same kind of issues of hierarchy and style. With variations to it to make it interesting. But the point I'm making here is that is actually just a digital model, really well detailed, digital artifacts. And here you can see that actual building and without its materiality just appeared as white massing systems. So you get the feeling that you're convinced that it really is an architectural model. So really impressive with what we're able to do with photorealistic types of modeling systems. I wanted to explain a little bit about how terracotta is created. I don't think I've gone into any depth with that, but here we have one of the panels that would be on that building. We're looking on the left side of what would be green terracotta, freshly out of the extrusion die. Most of the time it has this grayish color. It doesn't get typically that brick-like terracotta color until it's fired. Firing is just the baking at very high temperatures of this material to actually transition it from being a clay to being a more like ceramic product. So there's a real sophisticated change, or really interesting change in the chemistry of the material as it is fired. And in this case it's also glazed, which means that they fire it once to make it into the semi-ceramic terracotta material that it is. They coat it with a glazing system, and then they fire it again. And that's important to note, because when we glaze tiles to create that color, we're going through another firing process, and that increases the amount of embodied carbon that the product has. So on the bottom next to me here, that's just a kind of a close-up of what an actual extrusion die would look like. So here we're pushing clay through a shape that creates that kind of pattern that we see there. So you know, at one time I actually consulted for this company, but I've had the advantage to go back and visit them recently. And this is in their backyard. They have a graveyard of, they do a lot of historic restoration. So they have pieces of buildings that might have been shipped to them that they need to recreate that have damage on them. But they also have a graveyard of these mock-ups. So this is an area that's just filled with all kinds of different ceramic terracotta assemblies. They also have a showroom where they have these panel systems set up. And I'm really trying to give you this kind of virtual mock-up visit. And I'm introducing terracotta for you, to you, not because it's environmentally effective or important, because I've shown you that it's not. It could have a heavier footprint, but because it is a fluid material, you can actually generally shape it into anything. So in this example here, we have a rain screen system. These terracotta tiles are actually not extruded, but they're formed in what's called a ram press. So their shape is generated by pressing them into a mold. And you can see now that you can create all kinds of variations in the kind of patterning with it. So here we have a typical mock-up. I don't have the credit for this project, that's the little sign below it. But you see a close-up detail of kind of the massive elements that are there, the kind of really large expansive clip systems. Actually, you can see a little thermal break between the exterior clip and the channel that it's attaching it with that little piece of black washer that goes between it. But a terracotta facade. This gets back to that idea of plasticity. So here we have at the intersections of these curving columns and beam systems, we have this kind of like a T system that allows these two to merge together. And once again, to that idea of plasticity. So here we have kind of a picture framing happening at that corner condition of the window systems. And this is really where all the details are happening, and that's why they made this kind of a visual mock-up for it. Here's one that was part of what's called the ACAW, the Architectural Ceramics Assembly Workshop. The idea here was to use terracotta and put it under tension so that it could actually become structural in glass curtain wall systems. So that's why we have these aluminum connectors at the end. They've got tubes within them, and they're pre-stressing just like you would concrete the elements in order to make them stronger. And actually over my head, that's at full size. We had the close-up of that mock-up, and here we have the actual full-size mock-up with somebody standing in front of it. And I'm using this one to kind of talk about this idea of a virtual mock-up, which is what I want us to create in our project. So I've gone through that kind of experimentation. And we're looking on the left-hand side here of a virtual mock-up of a project that I did for experimenting with the idea of delivering this as a project to the class. And so we have this idea of what's happening with scale, with just a few of the details. Remember, we can create these kind of complex facade elements just by making one module and then repeating it over and over. In this case, I found remarkable, these are renderings that are done in Inkscape. The idea of getting a real feeling for the significant scale of these building components. Many times we can be drawing for days and really not understand the significance of the size and the mass of our components that we're building. But once you put on the VR headset and or insert people into it, you get an idea of really the kind of the massiveness of the elements we're designing. So in this case, I've got the white is a terracotta extrusion, and the bronze-looking thing is an anodized piece of an aluminum extrusion. At least a suggestion of a way of mixing materials together on a facade element. One of the things I might suggest in that kind of ability for us to explore and evaluate is now we can start to think about these components because we're building them in a modular fashion, not necessarily with the intention of modular construction, but we're really started well on the way to thinking about how to put these together in a modular way that can go either way in the construction. We can decide to build it, site build it in conventional techniques, and or break it apart and look at it as modules to be attached to the building. This is kind of a close-up of the level of detail that I built inside of this mock-up. So here we have the typical tracks that are for the attachment clips. I've added some additional bracketing to attach those channels to the building. So we have the plywood sheathing facade, we have the blue air water barrier, we have the yellow insulation, the mineral fiber insulation, and you can see on the clip I have that red idea of a thermal break. And if you look over my head, this is not unlike what we're seeing in this construction, which is a morphosis project. And I don't want to talk about it because it might still be proprietary, but it's these really wildly curved tiles attached to the building. And once again, we're seeing that green thermal break at the attachment to the wall system. And then it's just another detail that shows what the extrusions look like, how the clip systems are attached and brought back to the building. And that kind of just really concludes where I've gone with this. Then, this will end the lecture portion, and I'll reintroduce some of this stuff as I start to lay out the way we want to work our project through for this module next.